Hey everyone, welcome back to our SwiftUI series. In our last set of videos, we explored SwiftUI foundations. You can see these ones here with Apple's tutorials where we covered everything from views and layouts to buttons and lists. If you missed those, check out the links in the description to start from the very beginning. Today, we're stepping up to the next level with data modeling in SwiftUI. This is also part of Apple's Develop in Swift series, linked below. You can use this tutorial as a guide. I'll have timestamps for each of the sections below, so if you get stuck or if you want to follow along to make sure that you understand everything, I'll also give some helpful tips throughout the video. In this tutorial, we'll create custom types like enums and structs to handle our app's logics. We'll also explore unit testing to ensure everything works as expected, helping you write robust, bug-free code. Plus, we're going to dive into building game-style interface using grids and GridRows to tie it all together. Are you ready to take your SwiftUI skills to the next level? Let's go ahead and dive on it. So we can select the welcome to data modeling to learn a little bit more. So as I mentioned before, we're going to model our own data types in Swift to represent real world concepts. That's Swift testing. We're going to also be using Swift data, which we can use to power apps with any kind of data we can imagine. We're going to work with Xcode previews some more, and we're going to share and coordinate data models across complex apps. So here's a little bit more about data modeling. The previous tutorials, we went over updating the UI with state. We, created that dice rolling game. These models are okay for prototypes, but if we want to create something that we can ship out, and put it on the App Store, we're going to want to model more than one type of data. So what we're going to need is a familiarity with Xcode, Swift, and SwiftUI. So if you want to check out that previous tutorial, again, it's in the description. And make sure your Mac is up to date using Sequoia or Sonoma. And you don't actually need an iOS device to test these things. You can just use the simulator. So let's go ahead and get started with custom data types. So before we hop into the project, I just want to give you a quick preview of what we're going to be creating. We have a scorekeeper app where we have 3 different players. We can add and change their scores. We can even add an additional player and give them a custom name. If you follow all the way to the end of the tutorial, yours is going to look even better because we're going to do some unit tests and improve upon this. So let's go ahead and dive on in. All right, let's go ahead and get started. So we're going to create an app to keep track of scores while playing games and see how custom types can make your data modeling easier. All right, let's go ahead and create a new project here. Make sure we're in the iOS app template. Make sure we're on SwiftUI and language is set to Swift. Testing system and storage are just none. Let's go ahead and create our project. So the first step is we're going to create a property named players to hold the player's name. Because we're only concerned about each player's name right now, we can model each player as a string and it'll do what we need it to do. So we're going to create a state private variable under the structure content view, and we can go ahead and call it players. And we'll say that it's an array of strings. And we'll have it equal an empty array, and maybe we'll populate it later. We'll look at that in step 4. We're going to be adding some default names. So in here, we can add different strings of names. So if we wanted to copy exactly, we can do Alicia. After each string, you'll need to add a comma to separate those different items. I'm just going to go ahead and use the autofill feature here. Feel free to add whatever names you'd like. You can, of course, copy what's exactly in the tutorial if you want to have a one-to-one app. Now we're going to replace the contents of our V stack here. So we're just going to get rid of the placeholders, and we're going to use a for each view to loop over each player's index and the player's array. We're going to use a text field view to bound the entire entry of the players to display an editable name for each player. So let's go ahead and say for each. And here we're going to have some data. So 0 dot dot. I'm going to use the less than symbol. I'm going to say players dot count, comma, ID, colon, / dot description. Then we're going to use our brace here, index in, now we're going to create our text field. And within here, we're going to have a name for our placeholder. Then we're going to do comma, text, and then we're going to reference that binding that we created above. So we're going to use a $. We're going to reference players. And next to players, we're actually going to use square brackets. And we're going to put in index within those square brackets. So now we can see that we have all of our names. Next, we're going to be creating a button to add more players to the list. We're going to use append to add an empty string to the end of the players array once that button is tapped. For now, we're going to model a new player as an empty string because we don't know their name. People can edit the name of the new player after it's been added. So let's go under this for each here and we'll create a button. We can say add player and we can use the system image of plus, add a brace, and within this button we're going to say players dot append, and we're just going to actually have this be an empty string. So let's go ahead and press the add player button and we can see that a name pops up. That's what our placeholder was. So players can enter whatever name they would like here. Some bug I've found with the preview is that sometimes with entering into a text field doesn't work the best. So if we were to load this on the simulator, we can add a player here. I'll add the name Jackie. All right, next we need to add the scores. So every player is going to have a score associated with their name. We're going to do this by creating an array of integers with the player's score in the same order as their names in players array. As we continue to build the app, we're going to identify and fix crashes when our data model becomes a little bit more inconsistent. So we're going to create an integer array under our players here. So we'll do the same thing, state private variable, and we're going to go ahead and call it scores. And this time, instead of string, it's going to be integers. We're going to have this equal an empty array just for now. Just as a note, when we do have arrays, we're going to just have these strings be with other strings, and our ints are going to be on their own. So because the string that models the player can't keep track of both their name and score because we have one that's a string value and the other one's an integer, we're making this separate array. The first element in the array is actually represented by 0. So Alicia here is actually 0 and Noah would actually be 1. So we're just going to order it in the exact same order that we've done the names. In the for each view, we're going to add a stepper view so you can change each player's score. We're going to use the same index we've been using. So after this text field, let's go ahead and create that stepper with a capital S. We're going to, within a string, do some interpolation. We're going to say scores. We're going to have an index within here, comma, value. We're going to reference that binding of scores. And then we're going to have our index also within our brackets. But this is going to actually cause our preview to crash. This is happening because our data model is inconsistent, caused everything to crash there. We've modeled our data in 2 arrays with the index tying the player's name to their score, but our players array has 3 elements. Well, actually ours has 5, while the scores are empty. So just as a note, attempting to read an index that doesn't exist in an array causes a crash, index out of range error. So let's go ahead and fix this. So we're going to make the model consistent and we're going to add score values for all our players. In the tutorial, there's 3. And for my example, we have 5 different players. So I've added 1, 2, 3, 4, 5 sets of 0, each of them separated by a comma. Let's go ahead and refresh our preview now. So we can see that we have the stepper here. We can press the numbers. We can take away, we can even go to the negatives here, right? And now it wants us to press the add player button, and our preview has unfortunately crashed once again. What's happening is the exact same error we can see here, index out of range. So we've made our data model inconsistent, even though we didn't make any changes to the code. When we clicked add player, we added an empty string to the new player's name, but didn't add anything to the score array to match. So we created a player without a score, and now there's that inconsistency, it doesn't line up. So we can fix this by going down here, and where we have the players.append, we can definitely do the scores.append as well. And let's go ahead and set that to be 0 instead of that string. All right, let's go ahead and refresh it. And let's try to add that player now. It works fine. So if I were to add Bobby, again, my keyboard's still not working in the preview, but we can see we can assign them with a score and no more crash. Let's move on to section 3, creating our own player. So modeling players and scores in 2 different arrays, yeah, that's definitely been a headache. So we've definitely seen how every time we make a slight change in our code, we keep on having to kind of plug in holes and fix different bugs. It makes it super impossible for our data to be consistent. So instead, we're going to create our own player type to model all the data about a player instead. This makes it nearly impossible for our data to actually become inconsistent. So we're going to create a new Swift file and we're going to call it player. So if we go to the left side of our screen here and we hit plus, we're going to create a new file. And this time we're actually doing a Swift file, not a SwiftUI template. And we'll go ahead and call it player. All right, now within player, we're going to create a struct. We're going to call it player. Add braces, and we're just going to keep it empty for now. So the difference is when we're working with a blank Swift file, we don't have a preview, we don't see our phone on the right side, we don't have that view body set up for us. This is just a blank Swift file for us to create. And here we're going to be using the player struct for storing data, which we're going to display within our content view. So we're going to add 2 properties. First is a name, and the second one is a string. And the nice thing about this is, say we wanted to add things like date of creation, if we wanted to add other properties, it's going to be very easy to do so because we're going to conform it all within this structure. We're also using variable, so things like the name and the score can be updated or changed. Next, we're going to make the player adopt the identifiable protocol. If you're unsure what a protocol is, essentially a blueprint of methods, properties, and other requirements for a type. Meeting all those requirements is called conforming to that protocol. So think of it as like a set of rules that we're requiring player to conform to. So to add a protocol, we're going to use the colon. And just as a note, you can actually create your own protocols as well. If you want to learn more, I do have a video on those. And we're going to set it to be identifiable. So we're going to get an error because it does not conform to the protocol currently. And generally what you can do is you can actually click on errors with protocols and you can add these stubs for conformance. So what we essentially need to do is to make it conform, we need to provide it with an ID property. The ID of a player instance won't change even if the player's .name change, and now multiple players have the same name without SwiftUI getting confused. So if we have a whole bunch of Noahs, as long as they have their own unique ID, SwiftUI will know how to handle those cases, because SwiftUI uses this ID to tell the difference between a model changing and a completely new model. A UUID is a universally unique identifier, and using it guarantees that each instance of player will have a unique ID. So if I create 3 Noahs in a row, all 3 of those Noahs are going to have a different unique ID. So we can press the fix here, or we can go ahead and create an ID. So let's go ahead and establish an ID. We're going to have this say let ID equals UUID, and we're going to use some empty brackets here. All right, it wants us to return to our content view, and we're going to refactor our view to model our players as an array of player objects rather than as an array of strings and an array of int scores. So for an experiment, it wants us to take a look at the code and guess where we're going to need to update to use our new model, and then we're going to proceed to see if we're correct. So I'm going to do some guessing here. Well, I think our arrays are definitely going to need to be updated, as well as the players append and score. I believe the text fields, if we change the names and the scores here, I feel like pretty much everything is probably going to be needing a change. Step 6, remove our score array and update our players array to hold the instance of our new player type. Alrighty, so let's go ahead and delete our scores here, get rid of that. And for our variable of players, instead of string here, we're going to reference our player structure that we made in our other Swift file. Now you're going to notice we're going to get an error. As the tutorial suggests, you can actually use these errors to guide you in refactoring and fixing your code. So essentially what it's saying is, hey, you have a string value here, but you need to conform this to the player type. So if we remember with our player, and we can always go back to check, we had a variable name and a variable score. We don't need to provide it with that unique ID. So what we can do in our string is we can say player. Then we can reference the name and score. Our autofill is already going to help us out there. So if we have this first person be Alicia and their score to be 0, we can then continue this process. If you want to copy and paste to save some time, totally feel free to do so, especially if our score is just always 0. Let's do Andre. Make sure you have a comma to separate all these values, however. Go ahead and paste the last one, which is Jasmine. You will also need to put a comma at the very end of this as well. All right, next we need to update our for each loop to iterate over the players. So let's go ahead and delete everything within the brackets of our for each and start from scratch. So we're going to actually use the binding of players here. So we're going to use that $. Then we're going to add a brace and we're going to say $player in, so just player singular. So now we're updating the binding of our text field. So we'll say text field. Our default name here, text, and then we're going to use the binding player dot name. So we're going to access that name property. Go ahead and update our stepper as well. Well, I guess we got to recreate it because I deleted it. We'll use our string interpolation. So / player dot score, comma value, and then we'll do our binding. So our $ player dot score. And now within our button, we're going to replace those 2 append calls in the button's action with a single call that creates a player instance with a new name and score. So let's take both of these and we'll say players dot append P player, then name. We're going to have the string and score. So we're going to set this to be an empty string and then the score to be 0. All right, let's go ahead and experiment by running our app in the simulator. It wants us to adjust the score and adding players to confirm. That's impossible to get our data in an inconsistent state. So it's challenging us. Can we break this? So the first thing that we should check is if we have people with the same name, if it's going to freak out, or if that unique ID is truly going to handle those cases. So let's go ahead and add a new player, and we'll also call them Jasmine. Add another player, same name. Everything seems to be fine now. Each Jasmine does have their own unique score. Everything about that data is kind of in its own bubble. I think we're all good to go. The only thing I could really see happening is if we add a whole bunch of players, we kind of run out of space, but I think that's a separate issue where we might need to improve our app design a little bit. And we can also even see with people who have no names, they can still have a score assigned to them. All right, let's go ahead and add our app's title, tidy up the UI, and we're going to actually experiment using the grid view in order to make neat columns and headers for the player's name and score. So at the very top of our VStack, make a little bit of space here, we can create some text, score keeper, mine's just number 2. We'll add some font, this to be title. This is all things we've done before in these tutorials. We're just kind of styling how it looks. We'll also add some padding to be specifically on the bottom to create a little bit of a buffer in between those two things. Within our VStack, we'll also add some alignment, and we'll set that to be dot leading. So now we're going to wrap our for each in a grid view. Just as a note, unlike with embedding in HStack and VStack, there's no right click and embed in grid. So what we're going to do is we're just going to add our grid, add our opening brace, and then at the bottom of our for each, and you can always find where things kind of end by double clicking on the braces. We're going to add that closer, and we can see that the grid has encapsulated that for each. So grid and grid row views are great for horizontally aligning views within multiple rows. They work together to make sure each row of content is aligned in a perfect column. Think of things like spreadsheets, right? So let's go ahead and experiment with grid row. So after, that sounds like I'm saying like skid row. You don't want to go to grid row. So after the for each player's in before our text field, let's go ahead and add a grid row. So you're going to have capital G and capital R, and we'll make sure that our stepper is wrapped into it as well. So we have our grid, for each, and grid row. We're going to be adding another grid row, this time above the for each, but we're not going to be wrapping it this time. So under our grid, create another grid row. And this time we can just hit return to create that brace right underneath it. We'll add some text. We're going to have player and another text that's going to say score. And we can go outside this brace to provide properties to all of that, and we'll say font headline. Let's go ahead and refresh our preview so we can see how it looks. All right, now inside each player's row, we're going to add a text view that displays their score. This is going to make these steppers label redundant, so we're going to actually end up hiding it. So here within the grid row under the for each, we have our text field with our name. So in between the text field and stepper, we're going to say text, and we're going to interpolate player dot score. And now after the stepper here we can create some space. It's a little bit easier to see all these elements. After the stepper, we can add the dot label is hidden. Well, this looks so much better already. Now within this top grid row here, so above the for each, where we have the grid row with the player and score text, we're going to add a grid column alignment view modifier to the player's header. We're going to make it leading so it aligns with the player's name. So we can see right here that the score is currently lining up, but the player is kind of in the middle. Kind of want to adjust it so it's above the player. So let's go ahead and test that out. So dot grid column alignment. Do dot leading. Now the text that says player is more aligned with those player names. Next, it wants us to add padding to the entire grid view. So an easy way to find where our grid ends, let's go to this grid right here on line 23 for me. You can double click on it. You can see that we have our button outside of it as well. And we'll add some padding, and it wants us to set it to be vertical. Then we're going to add a spacer view as the last view in the VStack, so the contents are all pushed to the top. So if you need to find where our VStack is, you can go up here, double click. So within these brackets, so the one right above padding, add a spacer, and everything should get shifted on up to the top, which it does. Wonderful. If you want to test your app in the simulator, feel free to do so. Or if you want to do the preview, I've been having trouble with my text in preview, so I'll probably do simulator. Alrighty, welcome to Scorekeeper 2. You know, Alicia's doing great, Andre and Jasmine somehow has negative, and you know, Ricky's coming in, and Ricky's scoring all the points, right? So we can kind of play around with it. We can see, even if we continue to add people with multiple names, all their scores are handled separately. It looks cleaner. We use that grid to kind of create those columns, so everything feels so much more polished than it did before. Let's go ahead and check our understanding. If we have an array with 3 items, what happens if we try to access the 4th index in the array? An error is thrown or the application crashes. I'm going to go ahead and say that the application crashes because we kept getting that out of range error. When should you declare your own types? Never. Foundation types are all you need. Well, we learned that's not true. Always. Foundation types are never sufficient. Well, I wouldn't say that's true either. I'm going to guess it's sometimes. We have these more custom data models where we have things like integers and strings and maybe doubles coming into play. Creating our own structure of person seemed to really be the answer. And it's exactly that. That's the art of data modeling. It suggests that we think critically about what we want to build and whether off-the-shelf foundation types are sufficient or if we can make things simpler by building our own types. True or false to make type identifiable, make it conform to the identify protocol, and make sure that it has a UUID property. So a lot of people are probably going to say true here. The answer is actually false, and I'll show you why in a second. But essentially, it just requires that it has a ID property. It doesn't necessarily need to be. So when we look at our player structure here, if we were to delete this ID, we're going to get an error. And as I showed you before, where we have these stubs for conformance, so we press fix, all it requires is that it has an ID. This doesn't necessarily need to be the UUID. So if we go back to let ID, as long as this ID is kind of satisfied, you're good to go. However, I do recommend using UUID, especially if you're having things like multiples names be the exact same. All right, we answered all the questions within this tutorial, and there is an article that you can read for more information. And you can even expand your app as well as challenge yourself. However, what's next in the app is we're actually going to continue building Scorekeeper by defining another custom type to represent the core logic within our app. We're going to write some code that proves our app works as intended. And we're actually going to explore a little bit of testing, right? While we've kind of been creating these apps through the tutorials, we've taken some moments to test how they work, but we need to actually do a little bit more in-depth testing. Not to mention manually testing these apps can take a lot of time and it can be very tedious. So in order to address scaling problems for real-world apps, we can actually write automated tests as we do in the next section here. And we're going to focus on the smallest and actually most common type, which is a unit test. If you're someone who works in software development, you're probably nodding your head right now. So these tests actually only test a small piece of internal functionality in our app. And when they fail, they can really quickly help us identify bugs. So if you learn how to write these tests, you're going to save yourself so many more headaches in the future. Alrighty, so if you're ready to continue, we can go to the adding functionality with Swift testing by pressing get started here. You can also go to this top bar and scroll all the way down under new custom types in Swift testing, add functionality with Swift testing. Alrighty, in case you do need the project files, what we just created, you can download them here as well. Otherwise, let's go ahead and create the scoreboard. So designing types that are independent from our views makes it really easy to unit test our code. So we're going to model the logic of our app in our new scoreboard type to keep track of the players and their scores. We're going to have our content view defer our app's logic to this type. So if it's not already open, make sure that you have your scorekeeper ready to go. We're going to create a new Swift file. So let's go ahead and open up our project navigator over here. So just as a note, you can actually right click and use new empty file or use the plus new empty file. And we can go ahead and call it scoreboard. Instead of going from template, if you do it this way, it's just going to create an absolutely blank Swift file. Let's go ahead and import foundation and then create a structure again. And we'll call it scoreboard. Add braces and make some space. So the scoreboard is going to model the logic of our app. It's going to keep track of players, their scores, and the current state of the game. Creating types that are only focused on our app's logic without any UI code makes it possible to test our app's logic with unit tests, as we'll see in a little bit. So it's going to be in its own bubble. So we can add the player properties with a list of player instances. If we want to save some time, we can totally just steal this from our content view here. So we're going to grab our variable of players. It doesn't need to be a state private variable. So we can just copy from var all the way to the end of the array. Go ahead and Command C, go back to scoreboard, and let's paste it here. All right, we're going to go back to our content view and we're going to add the scoreboard property. We're going to assign an instance of scoreboard to this property. So above our player private variable, we'll do @state private variable scoreboard will equal scoreboard, the capital S to reference that structure. So like we did when we create our player type, we're going to refactor the content view to use the data from scoreboard instead of its own players array. This is going to make sure that scoreboard is the sole source of truth for the state of our app. So once we have the test that proves scoreboard works as intended, we can be confident to know that works no matter what. And it does have a note here. When we refactored the player type, we replaced the player's property right away and then fixed the compiler errors that came up. Here we're going to take a different approach and build the replacement alongside the existing property to avoid compiler errors. You can decide which way you like better with a lot of things with coding. There's a lot of personal preference. So let's go ahead. Something that I actually typically like to do is I'll actually use the refactor built into Xcode, but I'll make sure we go step by step to make sure you don't miss anything. So within our for each, where we have the players, we're now going to instead reference as our binding scoreboard.players. As well as in our button here, we're also going to say scoreboard.players.append. So with scoreboard now keeping track of the players, content view no longer needs its own player property. We can delete it. So let's go over here. If you wanted to keep this code for whatever reason, you can highlight it, command /, although the tutorial suggests we can just totally get rid of it. Players has essentially been made obsolete because everything's being handled through that scoreboard. All right, we're going to create our first testable method in scoreboard that's going to reset player scores. We're going to model the state of the game by creating our own game state enumeration, and then add a button that lets people cycle through the setup, playing, and game over states of our app. And finally, reset the scores when the setup has been completed. So we're going to create a new Swift file. Let's go to our project navigator over here, new empty file, and we'll call it game state. And within here, we're going to create an enumeration or enum with the enum keyword. We'll call it game state here. We'll add our brace. So if you're unsure what an enum or enumeration is, you can kind of think of it as a set. If I have a compass and I have north, east, south, west, right, we can use those to consistently have those 4 directions. So in the case of our game here, we might have the setup, playing, and game over as those 3 cases. You can't just randomly add in something that doesn't exist. So in step 2, it wants us to add those 3 cases. So we can do so by using the case keyword followed by what we want to call it. So in this case, setup, create another case for playing, another one for game over. So if these are our only 3, you saw it probably suggested pause for us. If pause does not exist, that's not something that we can use. You can kind of use it as like a set of rules. So we're going to go back to our scoreboard here, which is our Swift file, and we're going to add a state property to keep track of the game state. We're going to assign it a default value. We're going to use the setup from our enum. Another great reason to use enums is it also prevents spelling mistakes. So outside of our square brackets here, but still within that brace, we're going to create a variable state. We're going to reference the game state dot, and we can see all 3 that are available here. We're going to do setup. So as a note of values is an enum can include the explicit type as we've done here, but if the type can be inferred, then we can leave the name off the type, such as just using .setup instead of game state.setup. So later in the tutorial, there will be examples of that. All right, back to our content view, and at the very bottom of our VStack, so let's go ahead and double click on this brace here. So where we have our spacer, we can create some room within that. So we're still within that VStack. We're going to create a switch statement based on the scoreboard state. We're going to add a default case that displays an empty view. So a switch statement allows us to change behavior based on the value of the variable that's passed, almost like a huge series of if-else statements. However, unlike if-else statements, a switch statement requires us to define paths for all possible values of the expression, and a default case provides a catch-all when no previous values match. So we can create a switch using the switch keyword, all lowercase. We'll reference our scoreboard.state. We're going to add a brace, and we'll add our default, and then we're going to say empty view with empty brackets. So we're not done there with the switch. We're going to add the setup case to the switch statement. In this case, we'll show a button that advances the game into playing. So we can do so by referencing the case.setup, then a colon. After the colon is where we can add any code. So in this case, we'll have a button. We'll call it start game. We'll include a system image, and we can use play.fill to add our brace here. Scoreboard.state equals .playing. So because the compiler already knows that scoreboard.state is a type of game state, we can leave the type off the case statement and refer to it just as set. So remember, in our game state here, we had setup, playing, and game over. Let's go back to our content view, and we can just have that dot playing and dot setup. All right, we can add another case here. So after the braces of the button, we can add another case for when we're playing. Add the colon to add the code. This time we'll have a button that has the label of end game. We'll include a system image, stop.fill. This needs to be a string for sure. Add a brace, scoreboard.state equals .game over. So for the experiment, it says, what do you think will happen if we click on the start game button in the preview once, twice, try and if you see it was right. All right, so let's go ahead and load this up. So let's go ahead and press the start game. So now it has a button that says end game. So this should go to .game over. And now it's just gone. So I think what's happening is because it can't find game over, it's essentially just going to its default. And with default, it's going to empty that view. So it's just gone. All right, let's go ahead and add that game over case. So we'll do case dot game over colon. You can also copy and paste these buttons if you'd like. I'll just type them up from scratch. Reset game, system, image. I'm going to use arrow.counterclockwise. Let's see what that one looks like. And then our scoreboard state is going to equal .setup. So essentially we're almost creating a loop. So we go from setting up the game to playing and then game over. And once we've reset the game by pressing on that button, we go all the way back to the top. And we do have our default here to kind of catch anything. But you can actually see that we do have a little, not necessarily error, but more of a caution. So this won't actually prevent our app from running. It's just a suggestion that's saying that default will never be executed. So we can delete the default case to make it go away. So let's go ahead and highlight it and delete it. If you want to comment it so you remember, totally up to you. So in our preview, let's go ahead and press start game. We can cycle through the cases, end the game, reset, right? And now we kind of have this loop that goes from starting to ending to resetting. So So hopping back into our scoreboard now, we're going to add a mutating method to reset all the player scores. We're going to leave its implementation empty for now. So we can declare a function using the keyword func, followed by the function's name and an optional set of parameters inside parentheses. Functions declared within a type are associated with that type and are called methods. For struct types, you mark methods that might change using the mutating keyword. You can kind of think about mutating like variables. So if we type out mutating func reset scores, then within these kind of brackets, this is where we're going to have those parameters. And this is going to be to new value. And we're going to do colon integer. You can add a brace, make some space, and anything within these braces is going to execute when that function, or that method rather, is called upon. You also have a note. Starting with an incorrect implementation will make writing your unit tests easier. For this approach, the rule of thumb is to write the least amount of code that still compiles, because an empty implementation will compile. This is just what we need for now. All right, let's head back on over to our content view. We're going to add a property to keep track of the number of points that the players start the game with. Let's go all the way to the top. Under our scoreboard, we'll create a private variable. This doesn't need to be a state one. We're not using it with binding. I'm going to say starting points. I'll have this equals 0. So scoreboard can reset the player's score to any number with the reset scores to. So that function we just made. We're going to call this method when the game starts, but until then, we still need to keep track of the number. That makes modeling it as a property on our view an excellent choice. So now we're going to go to the setup case for our switch statements. Let's scroll down here. Here's our setup. And within our button, now we're going to reference that method we created within scoreboard. So let's reference scoreboard.reset scores to, and you'll see that it already fills in the 2, and we just need to write it with an integer. Well, we've created an integer above, which is that starting points. Okay, now we're going to create a unit test target. So we're going to be writing tests for our apps, and we need a place to write and run them. We can actually add a unit test bundle to our project by editing the project settings. So if we go over to our project navigator, if we click on the topmost one we have here, it kind of looks like a little A, almost like the App Store icon, where it has the name of our app. We can click on this. And within this project target list here, so you see it says project, scorekeeper, targets, right? We're going to press the plus button down here. We're going to get a new window that pops up. So targets are all the products Xcode can build in a given project. So we actually already have a target, which is the app itself. We're going to be adding an additional target for our unit tests to keep them separate from the app. This means we can build and run tests without launching the app, and more importantly, we can distribute our app without the tests. So under iOS, we're going to select the unit testing bundle. You can also scroll down here. See, there's different tabs. So this first one's extensions, then we have application, framework, and library, and it's already actually highlighted under test here at the very bottom for me, unit testing bundle. You can also use the search filter here to find what you'd like. So we're going to select that and press next. So unit tests focus on testing internal models and methods within our app. They're concise and easy to write, and they're what we're going to focus on within this tutorial. The UI testing bundle is for automating the testing of our app as a whole, like if you were to test it directly on our phone. For more information, there is a really helpful link within this tutorial. Okay, so we can just leave this name as the scorekeeper 2 tests. Make sure our language is on Swift. And we can go ahead and press finish. So now let's test and implement our method. We're going to write some tests based on how we expect our reset score to work. So essentially what should happen is every time our game resets, everybody's score value should just go to 0, right? And then we'll see if it meets our expectations. So this is actually referred to as a test-driven development. All right, in our project navigator on the left of the screen here, we can expand our scorekeeper to test folder. We can click on it. So the @test annotation here, so on line 12, marks this function as a test method. So here we have a function of example, right? Yours on your end might actually be called test example. The other two async and throws indicate that our method could use concurrency or error handling features in Swift. These are something that's way different. I do have some videos on concurrency and error handling if you want to check those out. There's also the documentation and I believe some other tutorials made by Apple. Feel free to check those ones out as well. So we're going to do some renaming here. We're going to rename the empty test method to reset scores. So function here, reset scores. And we can actually add a short title within brackets next to test. So reset player scores. So that string is how it's going to refer to our tests. So make it something detailed or with a description that you understand. It's important that we actually import our scorekeeper with the @testable, all lowercase, import, and then whatever we want to import. So in this case, scorekeeper2 or whatever the name of your project is. So just as a reminder, our test product is separate from our app product. If we were to upload this to the App Store, we wouldn't be uploading the tests, we'd be uploading that final app product. So this means we have to import our app scorekeeper in order to test it. So normally internal types and methods in your app aren't accessible from outside of it. However, because the scorekeeper test was built specifically for testing, you can access an app's internal methods as long as we import it with the @testable annotation. All right, we're going to write tests in a consistent style. First, we're going to specify a state of scoreboard. Then we're going to invoke the method or functionality that we want to test. And then we'll assert that the scoreboard has changed as a result of that method. So if we see in this kind of screenshot here, we have players with a whole bunch of scores. The reset scores goes to 0. And then we should see that all of those scores indeed have changed. So in reset scores, we're going to create a scoreboard with a list of players. Make sure at least one of the player has a score that is not 0. So we can highlight this kind of comment here, get rid of it, you can leave it, doesn't matter. Okay, a variable of scoreboard. We'll have it equals scoreboard. And within here, we're going to need to have our players. Then everything's going to be within that array. So we use those square brackets. Now let's have a player with name and score. So we can have Alicia with a score of 0, comma, another player. Let's do Andre as it suggests. And it did mention that one of them need to have a score. So let's make Andre score 5. This way we can make sure that it is indeed resetting to 0. All right, next we're going to invoke reset scores 2 in the scoreboard to set all the scores to 0. So after our arrays here, we're going to say scoreboard dot reset scores 2. I'm going to set that value to be 0. And we're going to loop over each player on the scoreboard. We're going to state with expect what we expect that result to be. So that should be 0. So we're going to say for player in scoreboard dot players, add a brace. We're going to use the, I like to call it the hashtag, I think it's actually the pound symbol, expect So what do we expect to happen? The player.score should equal. We're going to use that because it's exact 0. So that's the expectation. All right, let's go ahead and run our text using the Xcode product test command. So if you go to the top of your screen while Xcode is selected, you'll see product and then test. The hotkey is also Command U. Let's go ahead and test our app for the first time. Build succeeded. We can see that it's testing in the top here. It might take a few minutes. Oh no, what happened? Okay, let's go ahead and minimize our simulator here. We can see that we had our expectation failed. Our red diamond appears. If we want to learn more, under this left tab, we can see the reset player scores. We can click on it. We can actually learn a little bit more. So even though it failed, don't worry, this is actually a very important part of the process. This is why we wrote an incorrect method implementation to start. If this test had passed, you'd know that the test itself was incorrect and needed debugging. Because we know our score reset method does absolutely nothing, it's a way of testing the test so we have confidence in its results. It's not only do test, but you test the test. Just so you know. Alrighty, let's go ahead and open up our scoreboard. We can use the project navigator here, go to our scoreboard, and within that mutating function, let's go ahead and add some logic because essentially it was doing nothing. So let's say for index in 0 ... We're going to use the less than symbol here, players dot count, a brace players index dot score equals 0. Let's go ahead and test again. So we can use that Command U hotkey or product test. So we see that our app kind of opened, showed us the screen for a few seconds, and then closed. And we now have these glorious check marks saying that our test did pass. Congratulations. So while we could write multiple tests to alternate inputs to reset score, it's easier to parameterize our tests and have the testing framework do this for us. So let's return to our scorekeeper tests. I've already opened it up, and we're going to update the reset scores to take an argument, the value it will reset the player scores to when it's called. Within the function reset scores here, we do have those argument parameters, and we're going to say to new value int. So after our reset player scores within these brackets, we'll do a comma. We're going to add an arguments. In this case, we're going to add square brackets for an array 0, 10, and 20. If you want to test any other numbers, right, these are mostly just arbitrary, we can see how they work. All right, let's go ahead and run our test again with Command U. And as I say in the tutorial, we're going to notice we have multiple test failures. That's what testing's all about. So we can look at our tests here on the left panel. We can see the results of running our tests with each of the arguments. Well, actually all of my tests passed. That's interesting. Did I do something that I wasn't supposed to? Did I go ahead of myself? So apparently only the one with 0 was supposed to pass, but all of my new values were updated no problem. Let me know if you encountered the same thing. Let's go ahead anyways and hop into our scoreboard like it suggests on step 13. Within our function here, instead of the score equaling 0, let's set this to be new value. Let's rerun the tests. That was interesting. Well, our tests are completed and it still works. So that's interesting. I wonder, I might have made a mistake and just corrected it ahead of time, but hey, our test went through, everything works with both 0 and with the expectation. Alrighty, section 5, we're going to create a game settings view. So the points in Scorekeeper can represent any type of game points, from goals to scored health points remaining. Because players start some games with a certain amount of health or other points, we can add a view that lets people change the number of starting points for all players. Later, we'll add another settings option to this view. So let's go back to our project navigator. So we can click on the Scorekeeper to folder, the plus button, new file from template, SwiftUI view. We're going to call it settings view. Alrighty, it wants us to embed this text here within a VStack. So we can select on the text, embed in VStack. It wants us to give it an alignment of leading, as we did before. As well as some padding apparently, so dot padding. We're going to update this text to instead say game rules. We'll use a font of headline. And then afterwards, we're going to include a divider. Oh, whoops, I spelled alignment wrong. There we go, that's much better. It's like, I don't know what a ligament is. Okay, now that that's solved, let's go ahead and now add starting points property. To keep the track of the points each player should start with, we're going to use this with binding actually. So under our structure of settings view, we're going to do @binding variable starting points, which is going to be an integer. So a binding connects a property to a source of truth stored elsewhere instead of storing data directly. So including this does cause an error in our preview. We'll fix this in a couple steps. So within the preview, we're going to add an argument to the settings view. So we're going to say starting points, and then we're going to reference the binding of starting points. Also need to use the previewable macro, which uses dynamic properties inline in previews. We only actually use it within a preview body. So we'll do the @ previewable @state variable starting points, and then we can give it a value, in this case 5 if you want to follow the example 10. Now we're going to add a picker view whose selection updates the starting points properly. So you can use a picker when you want people to choose an item from a list of options. So after our divider here, we'll say picker starting points as like the kind of title, and then we can give it a selection. And we're actually going to reference our binding of starting points once again. We'll create a brace and open it on up. And within this brace, we're going to add 3 text views as options for the picker. We're then going to tag them with the starting point value they represent. So if we create an example of text 0 starting points, we're then going to add a tag with the .tag annotation. Because this one's 0 starting points, definitely make it 0. So that tag for the 10 is going to be 10, 20, so on and so forth. So text, let's go ahead and actually copy and paste this so we can save some time. Change this to be 10, and then 20. So we can click on the selection here, and we can choose which one we would like. Something to note as well, I don't know if it gets covered in this tutorial, but we can do .picker style. And from here, we can choose what it is. So we can use the dot. I really like the segmented picker. So if we did .segmented, you can kind of see they're in different rows. The wheel's also pretty fun, although I don't see too many people using the wheel outside of like timers, but if you wanted to play around with them, you totally can. I'm just going to go ahead and delete this as we'll just follow the tutorial exactly. So before we start making the value function, we're going to add a little bit of polish with the thin material. So after the padding, we're going to do dot background. So within these brackets, we're going to do dot thin material, comma, in dot rect, so R-E-C-T. We'll add a corner radius. Oh, sorry, not corner size, corner radius. And we'll set this to be 10.0. Now we kind of have this background effect going on here. Let's go back to our content view. So that's my first Swift file here. So within this content view, we already have our private variable. We're just going to transform this to be a state private variable instead. Let's also bring it on in line here so it looks nice and uniform. In the VStack beneath the title, we're going to add our settings view. We're going to pass the binding to starting points. So here's our VStack with the grid. So right above the grid here, we're going to add settings view. We're going to reference that. We're going to have the starting points. And we're going to reference our binding here with the $ starting points. Next thing we need to do, and you can also you can see our game rules. We have our different starting points. It does update here. So next we need to declare our winners. So we're going to iterate on our scoreboard model by adding a computed property that determines the winners when the game is over. We're going to provide multiple ways to win and test the property to make sure it chooses the correct winner based on game settings. So let's go over to our scoreboard. So in our scoreboard, we're going to add a does highest score win property. So this will determine whether the players with the highest or lowest score should be declared the winners. So if we're doing like normal sports rules or golf rules, as I like to say. So does highest score win equals true. Let's add a winners property to the scoreboard. For now, it's going to return all players. So here we'll say variable winners, which are player, the brace players. And as with before, our initial implementation is the least amount of code to get it to compile to make those tests easier. All right, let's go back to our tests here. So I'm going to open up my side panel, go to our scorekeeper to tests. We'll create a new test down here at test highest score wins. Have a function highest score wins. This is going to verify that the player with the highest score does indeed win. So let's go ahead and create an instance of scoreboard in the ideal state for testing a game with 2 players, one with a higher score. That's in the game over state and has the condition that the highest score should win. So we'll go ahead and say let scoreboard equals scoreboard with a capital S. So within this bracket, we're going to have some players. I'm going to open up an array here with those square brackets. 2 different people. We'll have Alicia, score of 0. And then we'll have another one. Let's do Andre again. And we'll set score to 4. So Andre should be the winner. After this array here, we're going to add a comma. We can make some space to make it easier to see. We'll add a state dot game over, comma, does highest score win, should be true. All right, and now let's create our expectation. So we're going to capture the output of the scoreboard's winner property, then state our expectation that this property is equal to an array that contains only the player with the highest score. We're definitely going to get an error. So say let winners equals scoreboard dot winners hashtag expect winners equals, then we'll do an array with our square bracket player name, reference our name and score, so it should be Andre. And this is case sensitive, by the way, so make sure you spell it the exact same, and the score is 4. So we're getting an error. That is because the expression expect requires types that it computes to be equatable, and player does not yet conform to that protocol. We're going to fix it in the next step. So we're going to open up player. So that structure we've created a long time ago. and we're going to actually include an extension. So after the structure, we can create an extension. I'm going to say player, and it's going to conform to equatable. So when we declare that a type conforms to equatable, Swift automatically provides an implementation that compares all properties of the type and returns true if they're equal. So however, this isn't what we want for player. Players with the same name and score should be equal even if they have different IDs. So just as a note, we're making deliberate data modeling decisions here about how we want player to be used. Because ID has a different value for each instance, it's more useful to check the other properties to determine equality. If we wanted to check whether two players were in the same instance, we can compare their ID properties, that UUID we created before, directly. All right, let's add our own conformance to equatable that returns true if two instances of players share the same name and score. We can do this by defining the equals equals method for the player type. So we'll create a static function equals equals. We're going to use kind of like some short form here of left hand side. So we're going to say LHS player, comma RHS for right hand side player. And this is going to return. So we're going to use the dash and the greater than symbol. So it kind of looks like a little error. Bool. So it's going to return a Boolean value. So we're going to say left hand side dot name equals equals RHS dot name. I'm going to use the double ampersand here so we can do the and LHS dot score equals equals RHS dot score. So this method's going to take two parameters whose only meaningful distinction is the order that they're sent to in this method, and it's going to compare their name. And with the double ampersand, it's also going to compare their score. Alrighty, let's go back to our testing. So our scorekeeper 2 tests here, or using scorekeeper 1. We're going to create one more test at test. Let's say lowest score wins. Do those golf rules. Create a function, lowest score wins. Want challenge, you can implement this test before seeing the implementation in the next step. We're just going to go ahead to make sure that everything's been in this tutorial here. We can basically copy most of what we have here within the highest score wins, except we're going to be expecting that Alicia is the winner with a score of 0, and that does highest score win is going to be false. So we're expecting Alicia to win, essentially, with a score of 0, because does highest score win is false. Therefore, the person with the lowest score in this case, Alicia with 0, should be declared the winner. Play with those golf rules. Alrighty, let's go ahead and run our tests here with Command U, or if you want to use the product test. If you're reading the tutorial on the right hand of the screen, they both fail. But they lied to us the other time, so who knows? Our tests have finished running, and we indeed have multiple errors. We can see here that the entire array of players were indeed the winners. You can see the results by clicking on them over here, as Alicia and Andre appear where they're not supposed to be. So we can see that our tests both fail, but this is what they should have happened because we haven't implemented the logic correctly yet. So let's go ahead and return to our scoreboard and let's fix that now. Let's go to our scoreboard over here. And under our variable of winners, let's go ahead and get rid of players here, and we'll say guard state equals dot game over, else return, we can have an empty array, and then we'll return players after. So we're using a guard statement to check that a condition is true and exit a function early if it is not. Now this closure has more than one expression and the return keyword before players. So all players with a winning score are considered to have won the game. create a winning score variable, and if statement that varies depending on the game rules. We'll fill out these conditionals and a following step. So within our variable winners here, we'll say var winning score equals 0 if does highest score win, add a brace here, and then we'll also be adding an else. So for games, when the highest score wins, loop over every player and save the higher of the player's score or the previously seen winning score. We're going to start with the winning score at int.min, so all player scores will be at that score or higher. So in this first if statement here, winning score equals int.min for player in players. Add a code brace here. Winning score equals max player dot score comma winning score. So the highest and lowest values an int can be are int.max and int.min respectively. Because you need something to compare the first player score against, we can use min as our starting value, so minimum and maximum. Now within our else, we're essentially just going to be doing the reverse. Winning score equals int dot max, so that should be a capital I, for player in players, and our code brace, winning score equals min player dot score comma winning score. That should be lowercase n. My brain apparently did like a swap up there. I did say inverse, so then my head's like, invert the capitals, apparently. I don't know. All right, we're now going to filter the array of players before returning it to only include players who have a winning score. So we're going to rerun our tests to make sure that all the tests now pass. So in our return, we're going to do players.filter. Going to add a code brace here. Player in player.score equals winning score. All right, let's go ahead and run our tests real quick. They should all pass. Oh, we did get an error. I remember I was saying that it was type sensitive. My Alicia was still lowercase. All right, let's go and run that one more time. And our tests have succeeded. Hooray. So now section 7, we're going to go ahead and crown those winners. So now that we're absolutely certain that scoreboard is declaring winners correctly, we can highlight the winners within the UI. When the game ends, we're going to add a crown next to all the players who've won. So let's go to our content view, and we're going to embed the text field for each player's name within an HStack. So here's our content view. Let's go down to our for each. We have our grid row here. So under our grid row, we're going to add an HStack. Open it up. We're going to close it after the text field. If you want to make it easier on yourself, you can also just highlight the text field or right click it, embed an HStack. This way you don't make any mistakes. So before the name, we're going to add a condition that's going to check whether that player is within that winner's array. If so, they're going to have the yellow crown. We can go ahead and actually pin this content view to make the next few steps easier to follow as well. So within this HStack above the text field, we're going to say if scoreboard dot winners dot contains. So it's going to check if it's within an array. Player, lowercase, we're going to add a brace. We're going to add an image. You know what, to make it easier on ourselves, let's go to the object library and we'll add the crown. We can just drag that into our code here. Then we'll apply a foreground style to make it yellow. If you wanted to create a custom gold color, feel free to do so. So it wants us to try it out, so let's go ahead and start the game. We'll give Jasmine some points. We'll end the game, And now Jasmine does have that crown next to their name. If we were to reset this game and everyone were to have 0, they'd all be winners. So they all get the crown. All right, let's hop on over to our settings view now, and we're going to add a binding. So add a binding here, variable, and does highest score win? And we'll say that this is a Boolean value, true or false. We will get an error because we do need to make sure that we've included this within our previewable as well. So we can add a comma here. You can also press here and add the fix. So I'll reference that binding of does highest score win. And we'll add a add previewable at state variable does highest score win. Say that it's a bool and it equals true, or if you want to do false, up to you. Okay, now we do have an error up here, which is going to make us go back to our content view, and we can see that our settings view here is also missing that binding within the initializer. It's kind of hard to see the code on the example here, but essentially, just like in the preview, we're also going to reference our does highest score win, except this time we're going to reference the binding of scoreboard dot does highest score win. All right, let's go back to our settings view, and we're going to add a picker with options for the highest or lower score to win the game. So under our divider, let's add it first here. Picker, win condition, add a selection, and we're going to reference the binding of does highest score win. We have brace here, text. So the first one will be highest score wins. And for this one's tag, instead of a number, we're going to use the Boolean of true. And then for the other one, we'll have it be false. You can add that text. If you want to copy and paste and save time, go for it. Lowest score wins. And the tag here will be false. Because essentially we're saying, okay, does the highest score win? Well, with highest score win selected, it sure does. With lowest score wins selected, it sure does not. I don't know where that bracket came from. And if you wanted to change the style of these so it's a little bit more, intuitive, up to you, however this would work. All right, we're pretty much good to go on our logic, so let's go ahead and improve our app design and wrap this thing on up. So in our content view, let's go ahead and disable both settings view and the player's name text field unless the scoreboard is in the setup state. So in our settings view, so we're going to use .disabled, and we're going to say when the scoreboard .state is not, by using the exclamation point, equal to .setup. So now if we start the game, you can see it's disabled. We can no longer change those rules. We're also going to set the opacity of the score column and the stepper control to 0 while it's in the setup state as well. So let's find our grid row here with our text of score dot opacity scoreboard dot state equals dot setup. We're going to use that ternary operator here, question mark 0 colon 1.0. Going to set the opacity of the add player button to 0 when the scoreboard isn't in the dot setup state. So let's find our scoreboard player append. So after our button here above our spacer, we have our opacity. We can do that ternary operator again, so scoreboard.state equals dot setup, ternary operator 1.0 colon 0. Oh, and that should be lowercase s on the scoreboard. Now we're going to center the buttons, so we're going to embed our switch statement in an H stack and place a spacer on either side of the switch statement. So underneath this spacer over here, here's our switch. Let's go ahead and add an H stack. And we can wrap our switch up in this. And now we can add a spacer on the other side. So let's see how it looks top here. Let's also go to the end of the switch statement here. We'll add another spacer. And that's going to put it in the very middle. All right, let's modify the H stack so that all the buttons have a consistent style, a large capsule shaped bordered button that's tinted blue. Cool, so at the end of our H stack here, if you want to double click on it to find the end, you can do so. We'll do dot button style, and we'll have this be dot bordered. Got an extra set of brackets there, an accent. We can also add the button border shape, and we'll do dot capsule, dot control size, be large. We can add a tint as well, which it suggests to be blue. And that's it. First of all, congratulations for making it to the end of the tutorial, and you have a pretty cool app as well as a much better understanding on how tests work and how we can actually use deliberate mistakes to ensure that our testing is accurate. So let's check our understanding. Select the true statement about test methods. They need to be annotated with test. You can't use the expect macro inside of them. They're easier to write after you've correctly implemented the method under test. So that first one here. So the test annotation is how the testing framework tests a method. So when I went here, we even created multiple tests within the structure. So we had the resetting of the player scores, highest score wins, and lowest score wins. Which of the following view modifiers hides a view, but only when the property should hide is true? So that would be the ternary operator here. So conditionally setting the opacity to 0 is a common way to conditionally hide a view. Final question, which is another true or false. Unit tests are for testing our apps as a whole. I'm going to go ahead and say false. Yeah, so unit test is much smaller than that. We're only looking at very, very specific things. We're kind of making sure our logic makes sense. I would say that like a UI test, that one we didn't select earlier, would be something to test for like phone purposes, where this is kind of more for logic and making sure functions work, right? So there is a article that we can read, and we can reflect on some concepts. I know this was a long one, but here we covered unit tests, bundle targeting. We had those enumerations for the playing, game over, things like that. We created a type to contain our app's logic, the structure of like the person. We used opacity to hide the views, disabled to turn off those controls, and we did a lot of testing, as well as reading their outputs in order to make sure that the results are desired. So if you want to expand this app, you totally can. You can even challenge yourself. But what's next? Well, in this next tutorial, we're going to learn how to use SwiftData to save our data between launches. So something you'll notice is when you launch your app and you close it, restart it, whatever, your data's gone. We can use SwiftData. You can even use things like core data to save that user's data. So we're going to be making an app that displays our friends and their birthdays. So that's what's in store for the next one. But thank you so much for watching. I hope you have an amazing day. Remember, dream big, code bigger. And if you enjoyed this tutorial, hit me up with a like, subscribe, drop a comment down below on anything you learned or found interesting. And I hope you have an amazing day. Dream big, code bigger.